And on stage, you have already John Strand, who is from Black Hills Info Security. He's also our sponsor, and you can find him and talk to him in a booth. You can make selfies as well. He's the Finn's most favorite author. So he followed actually my advice on going only without slides. And he is going to talk about cyber deception and adversary tracking, just showing how this actually works. John?
Thank you so much. I lied. One slide. By the way, whenever I'm talking with you, and we were at SciCon, I think it was, and it was like, you need to do this presentation, you need to come down to Latvia, and no PowerPoint slides. I got hives. I started itching. I was like withdrawals, right? So I have this one. You want to take a picture of it. I have a URL that you can go to, tinyurl.com, free labs free. It's a full lab environment. Everything I am doing today, you and your team can do. So it's not going to be a demonstration where you're like, that's really neat, and then you go party tonight, and then you're hungover, and you're like, can't remember anything. You'll be able to do absolutely everything that I do step by step, so you can train your team how to do these techniques. So just go to tinyurl.com, free labs free. Full disclosure, I had artificial intelligence create this picture for me. I love giving weird prompts. Like this prompt was, I want a sexy keyboard that says, don't touch grass, touch me instead. And that's what it came up with, and I think it did a very disturbing job of that. And I will put this up at the end of the presentation. So that's it. No more slides, except at the end I'll put that one back up. And now let's go ahead and let's get started. So the next presentation that's coming up is how to track adversaries based on the mistakes that they make. So what we're going to do is we're going to talk about how we can force adversaries to make those mistakes, and we can do it with cyber deception. One of the big problems with cyber deception is everyone thinks in terms of high interaction honeypots, right? Like we're going to put out a Windows 2000 box, and what are we going to find out? That a Windows 2000 box can be easily hacked. Does that improve our security posture at all? Not even a little bit. The other problem that you run in with many cyber deception solutions is they're very, very predictable. There's certain strings that you can use to identify those honeypot technologies, and I'm going to show you a little bit later how we can use artificial intelligence to dynamically generate the honeypot content for us, so the attackers are constantly getting a new view of any of the fake technologies that we're putting up there. And ultimately, this is all from my class on cyber deception, which is a pay-what-you-can class. You can take the class for $0. It's actually out on YouTube, the entire class, using the exact same labs that we have here. It's 16 hours of the things that I'm going to be discussing. But the first one we're going to be looking at, and I'm going to be going through the lab instructions. All of these labs are available to you. I'll put that slide up a little bit later, and you and your team can gain access to every single one of these. I don't have time to do every single one of these, but I'm going to focus on two of them. We're going to talk about attackers cloning websites for the purposes of trying to steal credentials from your end users, how we can deal with that effectively. And then the other one that we're going to be talking about is a honeypot tool called Beelzebub, which uses artificial intelligence to dynamically generate honeypot technology fingerprints so attackers can't easily identify that they've been trapped in a honeypot. So let's go ahead and let's get started with the first one. We're going to be talking about how we deal with site cloning. One of the most effective things that you can do is have a good understanding of the methodologies and attack paths that an attacker would go through when they're trying to break into your environment and put your deception technologies in those pathways. There are many vendors that just throw up lots of honeypots, and that's fine, but I prefer to put it in the exact pathway that I know attackers will use. And the reason why I know that attackers will use those attack paths is because I run a company that does offensive security engagements. We do over 650 to 700 security engagements a year, so we got a really good idea about where an attacker will go to exploit and also post-exploitation as well. So I'm going to be using Haroon Meer's site. This is Canary tokens. This is by the company Canary, and all of these honey tokens are free. You can actually stand up this entire GitHub repository in your own organization. So I'm just using their website for demonstration purposes because it works really well. Some of my favorites in here are fake AWS S3 creds. So you can put that on an internal GitHub repository, and if somebody pulls those down and uses them, you can get notified immediately. We had a really great pen test where we actually gained access to creds, but we gained access to the creds through the organization's internal chatbot. We went to the chatbot, and it was an all Linux and Mac environment. And there was no Active Directory to speak of, so one of those pathways that we use is taken away from us, but they did have a chatbot. And we chatted with the bot. We said, hey, where are the AWS keys? The chatbot came back and said, oh, the AWS keys are over here at this URL. Thank you, chatbot. Click the link, access denied. Couldn't gain access to the AWS creds. Went back to the chatbot and said, chatbot, how would one gain access to those AWS creds? Chatbot came back and said, oh, you have to be an administrator. How you being an administrator is determined is in your user profile. If you have in group memberships administrator, it'll let you in. Turns out that was completely modifiable by each employee. So they could go in and add administrator and automatically gain access to administrator level credentials to services. So we absolutely are hunting for these creds all the time. Another one that Sub-T, Casey Smith created based on some research that we had done is credit cards. You can put, they're real credit cards, believe it or not. It'll give you a real credit card number. And the credit card is interesting where the credit card will send you an email for pre-approval for any usage. So Canary uses that to check and see if that credit card is compromised because it should never be used and you can be notified that that credit card is compromised. There's lots of them in here and I don't have time to go over absolutely every one of them. So I'm going to focus on one of my favorites. I'm going to focus on the JavaScript cloned website. Let's talk about attacker methodologies. Whenever we're trying to break into an organization, one of the things that we will do is find authentication portals our customers are using, clone those portals, and then use those in a spear phishing engagement. This is standard ops for any offensive team, and it has been a standard operation for offensive teams for probably 2 decades now. But what if we can take this idea of threat intelligence and not just buy threat intelligence from a vendor, not just buy IP addresses and domains that are known to be bad? What if we could generate threat intelligence dynamically about what attackers are doing against our organization right now? This allows us to do that. So we have a website that has user ID, password, 2-factor authentication. We would clone that as an attacker, and then we would use that for spear phishing to intercept those credentials and log in as a user. But as defenders, we can mess with the attacker very, very, very effectively. How? Well, we can put in the settings the domain of the protected website. That's our domain. We know what that domain is. I'm going to put in blackhillsinfosec.com. So that's the domain of the protected website. It's not the fully qualified domain. It's just the domain of the website. And I'm going to put in my personal email address because I want to be alerted if someone tries to clone my website. And then I'm going to put in a message to myself of ha 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 ha. And I hit a key and everything went horribly, horribly wrong. All right, so let's do that again. Do not quite as many ha-has. And then I'm going to create the token. Now, what this token does is it generates some JavaScript. And it says, if I am executing on a website that is not equal to Black Hills InfoSec. So an attacker that would be attacking my company would use various substitutions for Black Hills InfoSec. They may try a 1 instead of an I, a 0 instead of an O, or Cyrillic characters that look similar, but it's different, to try to create a convincing fake version of my authentication portal, let's say for email. And this JavaScript will evaluate where it's executing from. And if it's not equal to this, then it's going to fire and it's going to reach out to Canary tokens and it's going to grab this 1 pixel by 1 pixel image. And that will notify us that this website has been cloned, and it's now, this code is executing from a website that is not owned by my company. An attacker is trying to execute it. But there's a problem with this. The problem with this is it's kind of obvious, right? I mean, just between you and me, attackers are never going to do this, but let's say hypothetically. An attacker goes through and reviews the code of the cloned website. Once again, never going to happen. But let's say that they do. They would get to this and say, this is bad. I'm not going to run this code. More than likely at that point, this is no longer a safe organization to hack. They're going to go someplace else. But what you can do is you can do this. You can click obfuscate script, and it automatically obfuscates the script for you. This is powerful for a couple of reasons. One, I can't read it. There's probably people in the room that can. That's special. I didn't date in high school either. I understand. All right? Now, what's also interesting about this is happening more and more and more with code in the past 18 months because of the advent of artificial intelligence. There's a lot of websites that are using AI to dynamically generate their websites, and a lot of that code looks like this. All right? So we can obfuscate it. I'm going to deobfuscate it because reasons. So I have this code, and it's been generated. And what we're going to do now is set up the server. All right, we're going to set up the server. Once again, following the instructions that are available to absolutely everyone in the room. The first thing I'm going to do is I'm going to become root on my Kali system. Then I am going to CD into a website that has an Outlook Web Access honeypot. For the record, if attackers see environments running on-prem Exchange with Outlook Web Access, they get all kinds of excited because you shouldn't be running on-prem Exchange. But you could do the same thing for anything that has user IDs and passwords. Could be a VPN portal, a web portal, doesn't matter. Just you're going to insert the code underneath the head inside of the HTML, and I'll show you what that looks like here in a second. Then I'm going to CD into templates. Oh, CD into opt, OA. Oh, I'm in the wrong system. There we go. That's better. There we go. All right, so I'm going to CD into templates. Too many Linux systems, said no one ever. All right, I'm in templates, and what I'm going to do is I'm going to edit the default Outlook Web HTML file. So this is just a fake Outlook Web HTML file that's kind of designed to capture credentials, but it's going to work for articulation purposes. And this is easy. Anyone with any level of technical skill can pull this off. We're going to go to the point of the HTML that says head, and then we're going to put in a script tag after head. Go ahead and put that there. Oops. Right below head, I'm going to put in script, like that. And then we're going to take that JavaScript, and then we're going to paste it in, and then I'm going to close that script. There we go. Now I've inserted this code into my web page. It's that easy. And remember, this will not fire unless someone scrapes the website and then runs it, because it's evaluating whether or not it's executing on blackhillsinfosec.com. You could also put in the obfuscated script if you want. Does that pretty easily. I'm going to clean some stuff out. I'm going to write it out, and then I'm going to close it. All right. So now we have inserted our honeypot inside of our HTML for our website. Now what we're going to do is we are going to go back one directory, and then we're just going to start up that example website. Right there. So we're going to do Python 3 OA. A lot of stuff in my command history. There we go. OAPOT. Takes a few seconds for it to start. And once again, this is just proof of concept code. It even tells you this is a development server. Never use this in production. It's just used for this class. So we now have our server up and running. I'm going to surf to it, and I'm going to show you what it looks like whenever I surf to that website. And by the way, all of this is running in Guacamole in Amazon AWS. I'm not running any of these systems on my local system. So when you see the IP address back to the United States, I think next to a good barbecue place, it's not here, it's in Amazon in the cloud. Everything is cloud-based, so you can run all of these labs in anything with a browser. It'll work just fine. So I'm going to grab this URL for the demonstration, and I'm going to open up the interwebs. There we go. I'm going to paste and go. There we go. So this would be an example of the website that the attacker has cloned. It's capturing user ID and password. I can put in test and test, and it's just running. But it's not associated with Black Hills Information Security. And because it's not associated with Black Hills Information Security, that means that that JavaScript is firing in the back end. So the attacker clones the website and is ready to launch a spear phishing attack. But as soon as they fire up the website and test it, it automatically triggers the honeypot in the code. Now, if I go back to canary tokens, I can scroll down and I can select Manage Canary Token. And it's going to say it's been triggered 2 times. So like I said, you can run this in their own website, but you can also go to the GitHub repository and stand up your own canary token server. All of this stuff is free. You can stand it up on your own. But now if I check the history, it's going to come back with the IP addresses that made that connection. There's the Carolina Brothers Pit Barbecue. I told you it was going to be next to a good barbecue joint. And this is actually an AWS data center because all of my stuff is running inside of this data center in the cloud. So let's take a second and let's try to drive home some themes here. Theme number 1, this doesn't fire all the time. If this was on Black Hills InfoSec's infrastructure, it would never fire. When an attacker goes through the attack methodology of cloning our website, I now have actionable threat intelligence before the attacker sends a single spear phishing email to my environment. That's threat intelligence. It's not threat intelligence about an attack that happened last week against somebody else. It's not threat intelligence about an IP address or a domain that's known to be evil a month or a year ago. It's actionable threat intelligence about an attacker getting ready to launch an attack against your environment right now. And at Black Hills Information Security, we have these types of deception traps all over because we know that we are being targeted by nation-state level adversaries constantly. Let me give you an example. We had a potential customer, just give you an idea of the sophistication that we're seeing with the attackers trying to come against BHIS. We had a potential customer that was in manufacturing in the United States. We were in negotiations with this customer, and we had sent a contract to that customer. We received an email from one of the customer's main points of contact saying, we have signed the contract. Please click this link over to Dropbox to download the contract. One of my contract managers downloaded the contract and her system was immediately compromised. We had a nation-state adversary that was on a potential customer's network watching for what that customer was doing and was dynamically using that access to attack other people, including us. That's nation-state level adversaries, right? So I love this because my SOC knows that we're under an active, targeted attack. And many times we know about that attack and where it's coming from before a single email hits our organization. So that's the type of threat intelligence that I think is incredibly powerful. And once again, this costs nothing. You can stand this up in your own environment. You can set it up. It took me like 5 minutes. You just need to find a portal that you think an attacker would clone, go to head, insert the JavaScript with a proper domain, and you're off to the races. You just wait for the alerts to come in. And it also supports webhooks as well. So very, very easy cyber deception that you can put in the actual attack pathways that an attacker would go down. So let's close that one out. And like I said, there's a lot of labs that are present here for you to do. I recommend you spending time. You have 16 hours of lab time to play with, but we have a bunch of labs from Spider Trap, Canary Tokens, Rita, Blue Spawn, Port Spoof, Honey Badger, Honey Share, how to set up a Honey user, and Web Honeypots. The next one we're going to talk about, though, is Beelzebub. And we're going to be using AI to dynamically generate the fingerprints that an attacker would see. Now, there are honeypots like Cowrie, which is an SSH honeypot, that has default settings. If you log into it, it always has the same IP address. If you look at the banner it gives you, it's always the exact same banner. So a standard vulnerability scanner will light up Cowrie like a Christmas tree, and it's very rare for an attacker to fall into a trap utilizing Cowrie and be able to miss it. The attackers see that it's a honeypot. In fact, this is very common, right? If I were to go to Shodan and do a search for SCADA in Shodan, I'm trying to find supervisory control and data acquisition systems, and a whole bunch of these Shodan is easily able to identify as honeypots because the strings and the signatures that are provided in the header for that application are known honeypot values. We see that again and again and again and again. So attackers tend to avoid those types of traps. So how do we do it in such a way that the attacker would not avoid it? How would we run it in such a way that the attacker would constantly be getting dynamic results that we don't even know what the results are? To do this, this is a tool called Beelzebub. And it's been great. We've been using this tool in my class for quite a while. It's also great because the author of this particular tool has great blogs where he's sharing information about attackers that he's caught in his honeypots. There's multiple honeypot services that it has. And it's got a Docker container, so it's super easy to deploy. It is fantastic. It has a number of different services that it can emulate. SSH is just one of them, and that's the one that we're going to be using here. So be sure to check it out. All right, so I'm going to close this one out, and here we go. Let me go that. There we go. All right, so let's go ahead and let's get started. So I've already gone through and updated and upgraded my VM, and I have Docker that's already set up, and I've already done the git clone. It just takes a few minutes to set that up. Now, I do want to show you what the docker compose.yaml looks like. One of the things that you have to do with Beelzebub is you have to give it API keys. To do this, we provided the link. You will have to have an account with ChatGPT. And there's multiple LLMs that you can use. I'm just using ChatGPT in this situation 4. And you go in and you create a new secret key. And when ChatGPT runs that key, I cannot stress this enough, copy it immediately. You will never be able to see it again. So the way ChatGPT works with its API keys is it'll show you the first few characters and the last 4 characters, but everything else is obfuscated forever. You'll never be able to see it again. And it tells you that. So let me show you what it looks like here real quick. So I'm just going to create a new key like this. And I'll just give it a name, kill me. All right? Just a default project, create this key. And now right here, it says, please save your secret key. You won't be able to view it again. Keep it secure. Anyone with your API key, like a con talk with a whole bunch of people in the room and a bunch of people virtually, would be able to use it. And then I would copy it, and then I would move it on. All right, so I'm going to delete these keys here in just a couple of seconds. So we'll get to that here in a bit. All right, so I've got that key, and if I have that particular key, I can input it here. Oh. All right, let me zoom in. and explain this configuration. It's really amazing. Beelzebub is written in Golang, and it's incredibly tight, very, very, very simple code. It's not highly complicated. So what it says is right here, these are the ports it listens on by default. I've commented out 22 because I'm running on a system that I'm SSH'd into, so I can't have Beelzebub listen on the port that I'm currently logged into. Instead, I'm using an alternate port of 2222. But it also sets up honeyports for like a TCP proxy, a web server, and a terminal service server as well. So it's not just SSH, it can also utilize prompts from ChatGPT to generate other honeypot services. You can use RabbitMQ if you want to get your messages and get alerting off of it, but then you put your OpenAI secret key here, and this isn't my whole key, right? So that's where you put your key, and literally Beelzebub goes to ChatGPT and it does a prompt that basically says, give me the output of this command without all of the ChatGPT stuff in the front and the end. I just want the results. What would you expect for a standard Linux computer system with this following command executed? And then it takes those results and then it feeds it back to the attacker. All right, so that is the services configuration. Now, we also need to go through and configure the actual service itself. So to do that, we would go into the configuration services file here, and then we would edit that services file. Now, we put in the ChatGPT API key as well there, but there's some additional services for it. So we can see the version, we can see the protocol is SSH, we got description SSH interactive ChatGPT, the plugin is the LM honeypot, server name is Ubuntu. These are passwords that it will accept. So you can put in a series of passwords. You got to make the attacker try a little bit. You just can't accept every password. But these are passwords that I see attackers run constantly. Root, I'm a little bit disappointed they don't have Tor. I don't know if we have any old school backtrack folks here, but root and Tor would have been cool. QWERTY, Smoker666, which is a little bit on the nose. I don't know. 1, 2, 3, 4, 5, 6, Jenkins, Minecraft, which makes a lot of sense. Sinus, Alex, Postgres, Lie, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So these are the passwords that it would accept. You can add in and remove those as well. So we set up that configuration with our key as well. Let me back up. And then we back up here. And now we're ready to start it up. I already have it running. You just basically do the Docker Compose build and then Docker Compose up, and then you try to authenticate to it. Alrighty. So now I'm going to authenticate to the server, put in the password of 1234 because that was in that file, and now I'm in. And we can change this prompt to just about anything, but I will tell you, no one's going to look at Ubuntu and be like, well, that's a honeypot. There's tons of systems that are called Ubuntu. Now, at this point, we're completely off-roading. I literally have no idea whatsoever what the responses are going to be coming back from ChatGPT. So if I do ls, it's going to take a couple of seconds, send it to ChatGPT, and ls is going to be like this right here. This would be normal. We got desktop, documents, downloads, music, pictures, public, and videos. This always makes me a little uncomfortable, but let's say I CD'd into videos, and then I type ls again. Now it's going to come back, okay, cool. It's not getting weird on me. I'm afraid it's like displaying hentai videos or something weird. We have movie MP4 tutorial AVI sample video.mov. We could do, let's CD space ... It remembers what was given. I could do ls -a. I can look for hidden files, and it's automatically, dynamically going to be changing up what it does. I could do ls -of -i capital P. ChatGPT is going to chew on that for a second, and it's going to come back and say, Firefox. Firefox is what's running. because that's what you would see as a standard user instead of absolutely every single service. But all of this is being dynamically generated on the fly for the attacker, which is incredibly powerful. Now, also on the back end, it is keeping full logs of everything. So I can do Docker compose. Let's go back here. And I can look at the logs, and then I can follow the logs, and I can see all of the different commands that are being run. So this is really helpful because if ChatGPT starts freaking out, you'll get messages from ChatGPT in real time when it's running. So let me see if I can give it a weird command, like make it easy to see if I can find that on the logs. It's going to come back and say command not found. There we go. And I can come back here and you can see that that command was executed down here with the coming back. So this is incredibly powerful, and it's powerful for a couple of reasons. It's powerful because it's dynamic and it makes it far more difficult for attackers to identify that they're in the matrix and they're trapped, number one. Number two, the other reason why this is powerful because this is threat intelligence of what the attacker is doing on your environment right now, not someone else's environment, what they're doing against your environment right now. And the final thing that I think is incredibly important for this is every single moment that an attacker is wasting time messing around with a honeypot, messing around with cloning websites with JavaScript that's going to immediately set off their IP address like a Roman candle, is less time that they're spending directly attacking your environment. I have this formula that I use in my class. Detection time plus reaction time must be less than the amount of time it takes for an attacker to successfully break into your environment. And in many environments, we don't really have control over the attacker's attack time. In fact, a lot of the recon and a lot of the initial attack vector stuff that attackers do, you would never see. But if you can start utilizing deception technologies in a way, then you're going to be able to see those attack methodologies. Also, a quick note on when you should implement this. It has been kind of standard belief in the industry that you should only implement cyber deception if you've done everything else correct. That is absolutely 100% wrong. Don't do that. It is not true. There are deception technologies that are so easy to implement and they're so effective, there's absolutely no reason not to implement them right away. I gave you two quick, easy ones that we can do in a 40-minute presentation. Another one that I recommend you all do as quickly as you possibly can is I recommend that you go to, let me go to my GitHub. I recommend that you go and look at my Honey User Lab. And my Honey User Lab is literally 5 minutes how you can create a Honey user in your environment. Once again, I'm going to share this with all of you once I put the slide up again. But one of the first things an attacker does when they gain access to your environment is they will initiate a password spray. And if we can do this in 5 minutes, creating a Honey user in our little lab environment, you can absolutely go to your domain controller, create a user, log into the user. It's a long story, but you have to log in. Otherwise, the last login date is January 1st, 1601. You create a Honey user, log into it, and wait. If you have an internal pen test, one of the first things that your internal pen test is going to do is an internal password spray. You will catch the internal pen test almost 100% of the time. And if you don't, your internal pen testing team isn't doing a very good job because that's what attackers do. They're going to go after these really easy things. So you shouldn't wait until you get absolutely everything done correctly. You should try to implement these things right now. They're low interaction, they're high return on investment, they're low false positives, they work fantastically well, and they cost you absolutely nothing in your environment. Now, a couple of kind of closing things. I put this link up. Like I said, I have like 38 labs that you can do and 16 hours of lab times. So please go to this URL to get signed up for those labs. The other thing that I have for you all, if you come to the booth, we have this comic that we've created. It's by Fred Van Lette is the author, and also some amazing artists. And I know that you've seen corporate comic books, and they're absolutely horrible. It's like, like the superhero is the vendor. It's like, X vendor saves the day. It's like, that's really bad. Fred is the author of Cowboys and Aliens. He's also done the Evil Dead comics for years. And he also wrote, there was a movie, it was a small independent movie that came out. Not a lot of people saw it last year, but he is one of the accredited authors for this little art house movie called Deadpool versus Wolverine last summer. So we've been working with him. It's a full graphic novel on the future of hacking. And in it is a bunch of cyber challenges. So when you see people initiate hacks in the comic book, you can actually do those hacks as well. And we have copies of that available for absolutely everybody. I've got a few minutes for a question. If anybody has any questions, I'd be happy to answer them. I think I can take one. You think that's about right?
Now we have around 5 minutes, so we can maybe take 2 or 3.
Okay.
Well, I'll kick it off because you mentioned already. I had a question that you already started answering about when is the right time when to deploy the honey tokens and honeypots. Well, honey tokens, in my experience, we usually don't do this. Mm-hmm. Well, it might be a good idea to start. However, but the question is actually, if we're doing a threat hunting operation, when we know that there's an adversary there, we see active, ongoing activity, we see where it's going, does it make sense at that point adding the honey tokens in path of the adversary?
Yes. My screen's gone, but it's okay. One of the cool things that you can do is if you know an adversary is sitting on the workstation, one of the things you can do is use a word web bug. So let me go back over here. Let's go to canary tokens. Let's do a new canary token. You can generate word web bugs. So that's weird. I think I know what's going on. Just give me a second. Apparently, there we go. All right. You can generate a word web bug or an Excel spreadsheet. And what you can do is put this on the desktop of the system that you believe to be compromised. So if the attack, and I love Excel spreadsheets because attackers don't like Word docs with macros. They hate them unless they're using them as an attack. Excel spreadsheets, they expect to have macros. The coolest thing about this is if the attacker downloads these files through their C2, they don't get mark of the web. So the active content that you put in for tracking that attacker is going to fire. And we also in the class talk about not just getting an IP address of an attacker, but you can put in a macro like netsh WLAN show networks mode equals BSSID, where you'll be able to get the wireless survey of where the attacker is and geolocate them within 20 meters. Great question.
Right. I will take also the questions from the audience. So just raise your hand so that I can see it. John, you saw it?
Yeah, I saw one right in the back right corner,
oh, yeah,
as far as
yes,
you possibly can get
back
from us. Oh, you're not going to run down there. Okay.
Maybe a silly question, but these are no-brainers. So what's preventing people from using this? Why they are not used? Typically, the lazy answer is that people are ignorant. But I don't believe in that. So have you figured out why people are not using these more?
Number one, the amount of people that are using them now than 5 years ago is exponentially larger. Okay. We see it all the time in our penetration tests where 5 years ago we didn't see it. Number two, I think that a lot of people have an idea of what a honeypot technology is a high interaction, lots of work, lots of effort, low return on investment honeypot. And that's one of the reasons why I go to these conferences and I teach this class for free, is a lot of these technologies are super duper easy to implement in your environment with high return on investment. So I think it's an education thing where people just need to break away from the methodology and the mindset that it's a really heavy infrastructure. We're standing up full servers and we can put these lightweight honey tokens throughout our environment.
Is there any other question? All right, I will read the question that is, well, I paraphrase the question that has been sent into the Menti through the QR code. So you added a honey token into the website whenever, as a JavaScript. Mm-hmm. So the question that that's been asked is there a way to show that it's not a script because the adversaries might just delete whatever is marked in the script tags? How can you obfuscate it there, like a notch more, if that is even a possibility at all?
They also have a cascading style sheet version of that. And most attackers won't delete CSS files because it's going to define how the website looks. So you can do it with JavaScript, you can do it with CSS. But the main premise is not very often that we see an attacker that goes through and scrapes out JavaScript, because literally JavaScript is the glue that makes websites work. And they would much rather have their website fire appropriately than have that risk of their cloned website not working. So it's very rare that we see an attack. Actually, I've never seen an attacker that scrapes it out. They just scrape it, set it, forget it. They never think they're being hunted.
Right. Any other questions? So for me, I have one last question before we go to the next speaker is, how do you automate it? Can it be an automated way of how, because you said you would go with the particular scenarios where you want to trick, right? So can you automate this? Do you actually have to do this? Is this a manual labor? How intensive this is? What are we talking here?
So this gets into how you deploy it from a political perspective. First and foremost, if you want to implement this in an environment in an automated way, there are vendors out there with products that do this. One of those is Canary. They automate and they rotate and they change and they morph constantly. And that's powerful. But getting that budget can be hard. So it's really important to be looking at the things that you have in the labs that I've given you, where you can get those quick wins and show management the efficacy of and the value of what you can get out of these technologies so that you can get the budget associated with utilizing a commercial solution that allows you to deploy it in an automated way.
All right. Well, thank you. And let's give an applause to John.
Thank you so much.